All right, thank you all for attending. So I have 90 slides and only 35 minutes, so it's going to be kind of a fast paced talk, but hope you enjoy. So fast forensics with these Yamato Security tools. First off, who am I? I'm originally from Indiana, where I spent the first 2 decades of my life. For whatever reason, I've always loved security and loved different cultures and languages. So for the past 2 decades, I've been actually working outside of the US, based in Kobe, Japan, doing about, still to this day, half offensive type work and half defensive blue team type work. So I'm really passionate about automating fast forensics because, as most of you know, once an attacker gets into your network, it can just be minutes or tens of minutes before they start wreaking havoc on your network. So incident responders need to be able to respond within. All right, seems like we're having difficulty. Hopefully this is working a little bit better. So incident responders also have to be fast enough. If your investigations are taking an hour or more, then oftentimes it's going to be too late. So when a lot of people talk about fast forensics, it seems in the past the emphasis has been mostly on data collection, but thanks to tools like CAPE and 50 other open source tools now, I think that problem has mostly been solved. So I've spent most of my time focusing on these other areas, enabling logging, detecting the incidents, processing the data, and verifying and triaging the results, which I'll talk about today. So Yamato Security is a community that I created in Japan because when I started, there was nobody really doing security where I live in Western Japan. And over the years, it's kind of grown into one of the largest communities in Japan. And the past 2-3 years, I got some volunteers together and we've been creating these open source differ tools. So namely Hayabusa, this event log configuration guide, Wella, and Takajo. So I'm going to be explaining about these different tools. First one is Hayabusa. Maybe you've heard of it or played around with it before. Just a quick side note, the past 7 years or so, I've been renovating this old Japanese house, and I've learned or had to teach myself how to do carpentry and electricity and all this stuff. But I found out that what I really love is refurbishing, for lack of a for a better word. So not throwing away any of this old stuff, but sanding off all the dirt and making it look better than it did originally. And I was thinking about it, and I realized that I'm basically doing the same thing with Hayabusa. But if I told everyone it was a refurbishing tool, probably no one really would understand. So first I explain it as a fast forensics timeline generator and threat hunting tool. Hayabusa in Japanese means peregrine falcon, so it's very fast. It'll go out and catch all of the different important events that you need for your forensics investigation. So log analysis is all about finding the needles in the haystack, or in Japanese, the phrase goes, trying to find all of the flakes of gold in the desert. So if you're out in the Sahara Desert trying to find flakes of gold, you're never going to be able to do it manually. You need a tool that goes out, brings back all of that gold, brings back all of those important events, puts it right in front of you, and now the investigation is very easy. So Hayabusa is not just for fast forensics on single machines, but thanks to Whitney Champion and Eric Capuano, we now have a plugin for Velociraptor. So you can push out Hayabusa to all of your Windows endpoints and send all that timeline data back to Velociraptor, the central place. And then now, even if that organization didn't have like a seam to begin with, you can kind of magically recreate a seam. So Hayabusa is all about automating the funnel of fidelity. So going from tens of millions of events and then filtering down to hundreds of unique alerts. So it's geared for enterprise forensics. We started around late 2020. And it took about a year to get the first release out because it was a lot of work. But after that, pretty much every month, we've been coming out with a new major release. It's written in Rust, so it's very fast. memory safe, multi-platform, can run on any OS. It's standalone, so you don't need to install any third-party .NET libraries or Python interpreters. All the rules are YAML and based on Sigma, so it's extremely easy to customize and extend. And we just released a brand new version 2.7 for all of you here today. So this is just, sorry, it's kind of hard to see. This is a visualization. Hayabusa, you run it on EVTX files. It'll create an HTML report with the results summary. It'll do a lot of nice processing, and it will spit out either a CSV file or a JSON file, which you can then import into your favorite analysis tools. So we have probably 99% native Sigma report. There's only one thing left we have to do before we're 100%. A lot of tools now are coming out with support for Sigma, but be aware that your mileage will vary between these tools. From what I've seen, Hayabusa, since the very initial release, has had the most accuracy with the highest amount of true positives and the lowest amount of false positives. It supports things like count, so you can do behavioral detections and detect things like password guessing, password spraying, things like that. We've added new features to the specification, so you can detect things that you can't normally with the vanilla Sigma specification. We've also added rules so that you get all of the different important events for your investigations, and rules are updated daily. So you run Hayabusa on as many EVTX files as you want, and then you get a single CSV file or JSON file. You can have Hayabusa spit out this event frequency timeline. So this is nice to visualize when you have spikes of volume. This is a screenshot of the HTML-based summary report. So immediately you can have a pretty good idea when an incident happened, the compromised host, and the techniques used. Now, we're not doing anything super advanced here. We're just telling you the dates with the most detections, the computers with the most detections, things like that. So of course, it's not 100% accurate, but in most of the cases when I've done this on real world incidents, usually it's pretty correct. Here's the list of all of the alerts, so you know all the different techniques and tools that the attackers have used. You click on any of these links and it will open up the Sigma YAML file, so you can check the detection logic and very quickly be able to figure out if this was a false positive or not. Hayabusa does a lot of data reduction. So going through, researching on Windows event logs, I realized that there's a lot of system noise, a lot of data that you can just ignore. So this is good so you can process it faster, analyze it faster, and I try to get everything to fit on one screen, so it's very easy to analyze. So there are many different ways that we do data reduction. This is probably because Japanese love to abbreviate everything into the most concise, efficient manner possible. And I think I've picked up that trait over the years. So I do everything I can to abbreviate everything. So for example, event message, if instead of saying a logon was attempted using explicit credentials, I just abbreviate it to explicit logon, things like that. This is a 4624 successful logon event example. On the left, it's kind of hard to see. You have this massive message that Windows will give you by default. It's over 2 kilobytes. Hayabusa will either do minimal at the top, so you can just get the important fields and extract out 69 bytes, or you can get all of the field data information, which is still less than 600 bytes. I also do channel and field abbreviations. So instead of saying Microsoft Windows firewall with advanced security firewall, which is unnecessarily long, I just abbreviate it to firewall. With the new version, we have duplication. So this usually reduces the file size by another 10 to 20%. So when you run Sigma rules, oftentimes multiple Sigma rules will hit on the same event. So if you check the details in the field data information, you'll see that all of that information is just being displayed over and over. So now if you turn on deduplication, you can just have it output once and then output DUP for duplication for the other events. So the maximum I've run Hayabusa on has been only 128 gigabytes. If you use the minimal profile, you can get that down to 18 gigabytes. If you use the standard profile and get all of the, don't lose any field data information, you still get that down to 28 gigabytes. And I don't know about you, but I'd rather be analyzing and processing 18 gigabytes over 128. Hayabusa does field normalization. So Windows logs are just all over the place. Each Microsoft developer just chooses their own field names. So for example, source IP address, I normalize all of these different various fields just to source IP. And then now it's very easy to grep or use JQ to pull out source IP or target IP, things like that. Hayabusa does log enrichment. So you can just get a free Maxmind account. And then now you have all of the geolocation, country, city, ASN information for all of the source and target IP addresses. And this is great for quickly discovering unauthorized access, data exfil, impossible travel, things like that. So sorry, this is kind of hard to see. This is a CSV timeline in Excel. And this is personally one of my favorite features. So on the right, we have this multi-line view. And normally the field data will just be on a very long line, just one line. And even with a super extra wide monitor, most of the times you won't be able to see all of the data information. So this would always really irritate me, having to scroll back right and left, hundreds of times a day, or, double click and open in a new window. I don't want to deal with that. So I just delimit it with new lines. And then now, even on a normal sized laptop monitor, you can have all of the information right in front of you and very quickly be able to determine if it's a false positive or not, things like that. Another new feature that just came out today, thanks to Fukusuke Takahashi, is field data mapping. So instead of having all of these cryptic codes like %1832 inside the Windows event log, we now map that all to human readable messages. And last but not least, all of the output is customizable. So different analysts, I'm sure, have different preferences on what data they want to output. And depending on your situation, you probably, sometimes you may want to output more data, you may want to output less, and that's all very easily customizable. So hopefully this refurbishing analogy makes a little more sense. On the left, we have the original XML Windows logs that don't look so great, and I shave off, reduce all of the unneeded data, and present it a little bit nicer in a format that is ideal for forensics investigations. So Hayabusa has a lot more features, but I don't have so much time right now. So if you want to read about the other features, just check out the README. Of course, there's going to be limitations in any security tool that you use, offense or defense. So Hayabusa is meant for fast forensics and triage, not for 100% thorough analysis. So one day we'll probably get there, but in the meantime, understand your tool's limitations and what they do in the background. And if you want us to add more events to Hayabusa, just send us an issue on GitHub, and I can probably add that event within a day or two. You will get false positives. This is by design. So Sigma rules are not all very specific Sigma rules or have a very specific detection logic, because the more specific your detection logic is, the easier it is to bypass. So intentionally, there's a lot of generic rules as well in order to detect new tools and techniques. So sometimes you get some arrogant red teamers that are so happy, I can bypass some Sigma rules, that's great and all. It's easy to bypass a few specific Sigma rules, but it's much more difficult to bypass thousands of generic Sigma rules, especially if you haven't had access to that machine yet. So in the end, you will need a DFIR professional to confirm the results, which is very good for all of you. You'll all have very good job security, I'm sure. So the next topic I want to talk about is this Yamato Security's event log configuration guide. Sorry, it's a very long title. I wrote up 2 rather long documents, and I looked up all the different Sigma rules, and I wanted to find out what Windows settings needed to be enabled in order to detect things with Sigma. So I found out that only about 10 to 20% of Sigma rules can be used with the Windows default settings, and that's not good. If you, during your preparation stage, enable all of the different Windows event logs, you can now use up to 75% of Sigma rules. And if you want that last 25%, you will have to install sysmon. So here's just a list of the different important ones. One thing to remember is the most important event is for process creation. So either sysmon event ID 1 or security 4688. And you want to make sure that command line auditing is also enabled. So that's about half of the Sigma rules rely on that. And this is just another graph showing that you need to proactively turn on these settings in order to detect things. So it doesn't matter if you have the best detection rules in the world if you don't have the logs to begin with. So this is just a snippet from one of the documents. I wrote up 2 different documents showing what's enabled by default, what's the recommended settings. If you turn on something, what event IDs get enabled, and what kind of attacks are you now able to detect. We also have a batch script. So if you want to just do this in a test lab, just run that batch script or use your favorite baselines. But at the end of the day, you need to make sure you know what data is needed for your detections. Make sure you enable it, tested it, and make sure it's also not too noisy. So don't overdo it as well. So that's easier said than done, but very important process. The next tool is Wella, which stands for the Windows Event Log Analyzer. So I was drinking too much coffee, couldn't sleep at night, and I decided to create this tool. It does a few things, but kind of the flagship feature is creating this log on timeline. So it takes all of the important information from these multiple Windows events like 4624, 4634, et cetera, and then it consolidates all that information on a single line. And furthermore, reduces about 90% of that system noise. So I apologize, this is very difficult to see here on the monitor, but I'm calculating the log on time, the log off time, elapsed time, things like this, putting all of the information you want to know on single lines. And in a lot of cases, you don't even need to run like Sigma detection rules in order to detect attacks. Just by looking at this log on timeline, you can see when there's suspicious timelines and lateral movement and things like that. I hope you didn't like this tool too much because as of today, I'm officially deprecating it in favor of Hayabusa and Takajo. So Takajo, it's been around for a while, but whoops, we lost, oh, we got the screen back. So Takajo, it's been around for a while, but I just uploaded a new version today with a lot of different useful features. It means falconer in Japanese. So the image is that you send out Hayabusa to get back all these events, and then you can use Takajo to further analyze those results. It's written in NIM, so just like Rust, it's memory safe, super fast, but unlike Rust, it's extremely easy to write. So it's, in my opinion, it's easier to write than Python. So if you wanted to add new commands, it would be very simple to do. So far, we're just getting started with this tool, but we have list commands that let you extract out domains, IP addresses, and hashes. Split commands, so you can split up your CSV timelines. So if you have a big CSV timeline, I like to use Timeline Explorer, but usually if the CSV is over about a gig or so, it starts to get slow. But if you split everything up by computer name, usually you get like 500 megabyte files, which will run and load super fast in Timeline Explorer. Stack commands does frequency analysis. We only have one for logons right now, but think of like Kansa style stack analysis. I'm going to be adding a lot of these commands so you can start checking for outliers. Sysmon process tree will create a process tree of malicious processes. So if you find a malicious process, you just put in that process GUID, and then now you don't have to manually go searching and finding out what the parent is, was that parent process spawning other malicious processes, etc. Two different timeline commands. So we got the Wella style timeline of logons and also a timeline of suspicious processes, which basically just gives you a timeline of all of the different malicious commands that the attacker ran. And then finally, virus total commands. So if you have a virus total subscription, you can now look up all that domain IP and hash information and get threat intelligence. So I didn't want to just talk to you about the features. I wanted to kind of explain it with a real world or near real world scenario. So recently I've been taking SANS 608, which is the enterprise forensics course. And I wanted to see how Hayabusa and Takajo stacked up to the CTF on the final day. So one of the cool things about this course is on the final day CTF, you're about 4 or 5 people, and they give you almost 100 gigabytes of EVTX data to analyze and only 4 hours to do it. So that was the challenge to see if I could do that. The objectives are just like a normal incident response, try to find patient 0, find out what happened, etc. So the hardware I used was a 2017 older machine. At the time was pretty good spec, but if you're running like a more recent computer, especially an ARM-based Mac, you can get about twice the performance. But I wanted to simulate what most people have and most SANS students had. So for all the benchmarks, I am using this older hardware. So the first task is, how do we process the data the most efficiently? So just by running a normal scan, we get from 88 million events down to 18 million events, which is much better. You get a 11 gigabyte CSV file. However, this takes over 3 hours. So by the time it's finished, you're probably going to be sleeping and you won't have time for analysis. So the problem is that Hayabusa is loading too many rules. So if you consider process creation events or rules are actually 2 in 1, that's almost 4,000 Sigma rules. And the key to fast scanning is to only enable what you need to. However, too few rules is also not ideal. So Hayabusa is not a SIEM with indexed data. So just scanning for one event will take you 26 minutes. And if you try to do that 4,000 times, it's going to take you over 70 days. And who knows if you're still alive by then, right? So the solution I came up with, super simple, divide and conquer. So you want to split up your logs, and I found out that the sweet spot seems to be by scanning with either 2 or 3 scans. And then you've got teammates, so then have different analysts review those different results. So in the new version, we have a lot of new filtering features, so you can filter in and out on anything you can think of, event IDs, computer names, tags, categories, etc. We have a computer metrics command. Takes 20 minutes to process, but now we know that the mail server has 27 million events, the DC 12 million, and everything else is less than 10 million. So you could have one analyst taking care of the mail server, which takes about an hour, another analyst handling the DC, which is 45 minutes, and then the last analyst handling everything else, but that still takes about 2 hours. So still, we've got room for improvement. Another method would be to scan for just high and critical alerts, try to find the most compromised machines, and then do deep dive analysis on those. It sounds good in theory, but it didn't seem to work so well in this scenario. You can now filter in and out on tags. So for those of you who just want to hunt on persistence or just want to hunt on lateral movement, things like that, that's now possible. Another method would be to divide by sysmon logs and non-sysmon logs. Doesn't work out so well in this scenario, but if you have a Windows machine that doesn't have sysmon and logs, you should disable those sysmon logs, and now you can process everything twice as fast. EID filtering, I also recommend, so that will give you about 20% faster. It'll only scan the EIDs that are known to have detections. New feature called proven rules. I found out that only about 35% of Sigma rules have been proven to work, like on my data sets. So most seem to be experimental. So if you load only the ones that have proven to work, you'll still get near 100% accuracy, but now the processing time is about 50% faster. Last but not least, this has been around for a while, but I'm sure this is being very underused. I highly recommend, if you know when about the incident happened, definitely use these time filters. So in this case, we knew that the incident happened in early 2020. So if we specify this timeline start line or start command line option, not only will the processing be much faster, but also your analysis will be faster and easier. So inside these logs, there's also data back from the 2018 incident. So the first time I was looking at this, I was getting artifacts from both incidents all mixed up, and it was really making my analysis slow. So you should definitely try to utilize this when you can, and this will give you a 60% time increase. So the best method that I've come up with so far is using all those tricks that I told you. If you enable all these, command line options, now we've taken our scan that takes over an hour, and we've reduced it down to only 18 minutes. The DC goes from 45 minutes to process to only 16 minutes. And everything else, we've gone from 2 hours to about a half an hour. And then again, afterwards, you want to split up those CSV files so that you have very small CSV files to analyze in Timeline Explorer. For those of you who like Time Sketch and Elastic Stack, you can do a similar thing by creating a JSON-L file. So second task, analyzing the data. Of course, I can't give you a walkthrough of the CTF or spoil anything, so it's just kind of some general advice. In the past, I would normally teach people to check all of the unique alerts, go in priority from critical to low, and even if you have over 20 million events, oftentimes you only have hundreds of unique alerts. So if you're triaging by unique alerts, this becomes now practical. If this was a large scale incident, you could spend weeks on this and get through all those alerts. However, we're focusing on fast forensics today. We want to see what we can do within an hour. So in this case, this methodology takes too long. I decided that this methodology is a little bit faster, or much faster. So you want to set your goal to identify and create a timeline of all of the high layer events. So things like compromised machines, accounts, exfiltrated data, lateral movement, etc. And the way you do this is not by focusing on any individual alert and doing deep dives into those, but to focus on pivoting on keywords. So things like the malware file name, C2 servers, backdoor account names, things like that. And then once you have all that high level timeline, then start doing deep dive analysis and fill in those gaps. So suspicious process timeline takes 10 minutes to do. And as I mentioned, it will create a timeline of most of all the malicious commands that the attacker ran. So I don't know how more easier it can get than that. You will need to filter out noisy events. And most of the time, it's just a matter of going to Timeline Explorer, just choose a does not contain, and then in my case, I just filtered out 4 noisy rules, and I went from 100,000 lines down to only 600. So oftentimes it's just filtering out those noisy rules. So in less than a minute, I was able to find out when the incident happened, what machines were compromised, attacker accounts, etc. So using the pivot keywords list, if you just search on critical alerts, within 1 minute, you can now identify the attacker's accounts, source computer, and suspicious processes. If you're looking at high alerts, you can identify the attacker's IP addresses, lots of malware, and lots of compromised accounts. And this will probably take about 10-20 minutes. Logon summary and timeline, I was able to quickly identify the accounts targeted, computers that the attacker had access to, and lateral movement. Also, I was able to find an uncrackable plain text password that somebody accidentally put in the username, and it got logged in the failed event log, which I thought was a little funny, but this definitely happens. So in the end, of course, analyzing just the Hayabusa results is not, insufficient. There are still rules that need to be created, and you're going to have Mac machines, Linux machines. You'll have to look at other Windows forensics artifacts. But you can get about 80% of the analysis done in about 20% of the time, which is the goal of Hayabusa. So hopefully that's a win for Hayabusa, even if you're running, older hardware with some teammates. You're now able to process and analyze, almost 100 gigabytes of EVTX data in less than an hour. So I consider that a win. If you want to check out our tools and researches, just search for GitHub and Yamato Security, and all of our stuff is on GitHub. So lots of future plans. As I said, we're coming out with new releases, almost every month. The thing I'm most excited for now is being able to import into SoftElk. So I'm going to be working with Phil Hagen with that, and you can just drop in a JSON L file into a directory, and then now all of the events are loaded into Elastic Stack, fancy dashboards, blinking lights, and things like that. Many thanks to all of the amazing people at Nextron Systems who have created and maintained the Sigma project. Many thanks to Mike Pilkington for letting me use the 608 CTF logs for this example. And last but not least, much big thanks to all of the Hayabusa developers who have made this possible. So if you want to contribute or support the project, there's lots of things to do. So just reach out to me, and I can figure out something for you to do. Anything, tweets, blog write-ups, GitHub stars to show your support will definitely give motivation and to the developers. And I'm actually finished on time. So try out our tools and resources. Let us know what you think. And that's it for me. So thank you for listening.